since we are dealing with trig functions, we will be working with a Cartesian plane. But the Cartesian plane isn't the same as what we are used to. Because before I would take whole numbers for x and whole numbers for y. In a Cartesian plane, my horizontal variable is a degree. It's theta, or if I'm calling the degree x, it is in degrees. My y-axis is still the way I remember it, counting in whole numbers. So we will still need a Cartesian plane. X or theta is my input in degrees, or the domain. Have a look at here. Okay, and my y is still my values on the y-axis and still in normal whole numbers. So I could call it x, I could call it theta, but it is definitely in degrees. And that is my horizontal axis. And then I'm going to have my y is my output in whole numbers. And that is my vertical axis. Now, just as before, when I have anything on an axis, the spaces have to be consistent and the increments have to be consistent. So the standard increments that I use is 90. So 90, 180, 270, 360. That does not mean that I can't change it up and make it 30, 60, 90, 120, 150, 180, and so on and so forth. It's just the standard is 90 degrees. Just like the standard for us normally is 1, 2, 3, our standard is 90 degrees. So just showing you what this could look like. For the sake of difference, I'm going to call it theta for my horizontal and still y for my vertical. We still meet at the origin of 0, 0, so it would be 0 degrees with 0 y. Same spaces, measuring 1 centimeter. I'm going to measure 1.5 centimeters just to make it a little bit bigger. Okay, so I just made it a little bit bigger, so those little lines, just ignore them. But it is 90 degrees. 180 degrees, 270 degrees, and 360 degrees, which means it would be negative 90 degrees, negative 180 degrees, and negative 270 degrees, and negative 360 degrees. And at the origin it would be 0 degrees, and I'm going to just go 2 lines for 1 and then 2. Minus 1, minus 2. I'm only making it slightly bigger because we're going to have some information on it. It's a little annoying. You can if you want to, it's not going to make a difference, but to me it was annoying. Now we are going to deal with 2 of our functions. I will show you tan, but tan is definitely not being asked. Okay, I will show it to you. You haven't seen it before in your investigation, but cos and sine is what we need to know. So just like our other functions, we do have a standard form. We have a mother graph that is not shifted up or down, just like we had with all the other graphs, and then we would have a shift up or down as well. We do not do left and right shifts in grade 10, that is a grade 11 issue. So our standard forms, and I'm going to show you the cos and the sine standard form. So just moving that up for now. Okay. So standard form for trig graphs. So it would be f of x or y or whatever equals to a. I'm just going to say sine or cos or tan for that matter, but we're not dealing with tan, so we can just leave tan out. Theta, now we all know that theta can have stuff in front of it, plus or minus as well. So we'll just say p theta. So I just arbitrarily called it p. And we can also have a plus or minus q for the shift. If it is at the origin, there is no shift and we would not see a value there. Now, just like before, different parts of these equations can be told from the graph or are considered different things. Okay? So, my A value is my amplitude. We will write a definition for amplitude in a moment. Could be positive, could be negative. So yes, it tells me if the graph is positive or negative, but the value, the number, tells me the amplitude. This p in front of the theta influences the period, which we will also chat about in a moment. And lastly, this q value here is the shift. Positive for up, negative for down. So I could have something like 2 sine 5 theta minus 3. Telling me that my amplitude is 2, my period is influenced by that number 5, and plus 2 is how it shifted up by 2 units. Which means nothing if we don't know what the graph looks like. So that's our next step. So there are some things we're going to write down. I'm just thinking theory or picture first. Let's do picture first. Okay. So you're welcome to draw in the same Cartesian plane, the same other graph for cos and sine, but I'm going to do it on 2 different graphs. No, I'm going to do it on the same graph. Okay, so I'm going to draw a new Cartesian plane. You're welcome to use the one that you drew. So what I'm going to do first is I'm going to give you the fact that I'm doing y equals to a simple sine theta and y equals to a simple cos theta. And I'm going to do it for the full range from negative 360 to positive 360. So I'm just drawing a table. I'll also show you on your calculator how to do this and make your life a little bit easier. Okay, so you can at least draw your table so long. So you can, and I do suggest that you practice your calculator work. Go and say sine minus 360, get a value. Sine minus 270, get a value. Sine minus 180, get a value, all the way to 360, and write it into your table. Okay, so I'm going to try and get this on nicely. So I'm literally going sine 360, negative 360, sorry. Negative 360 equals, I get 0. So I write it in. Sine 270, negative 270, and write it in is 1. Sine negative 180, write it in is 0. Sine negative 90 is 1, and I write it in. Oopsie, negative 90, what am I doing? Negative 90 is negative 1. Sine 0 is 0. So I'm doing this on my calculator. Sine 90 is 1. Sine 180, positives now, is 0. Sine 270 is negative 1. And sine of 360, positive 360, is 0. So I'm going to repeat that, do it with cos on my calculator and get the values. Okay, so it will be 1, 0, negative 1, 0, 1, 0, negative 1, 0, and 1. So there's nothing wrong with doing it the way I did it with sine, where you physically go sine negative 360, sine negative 270, sine 180. Or if you have a Casio, you can do the following. Okay, so I'm going to try and keep it in view. Press mode, and you'll see it comes up with the options of 1 comp, 2 stat, and 3 table. 1 means computer, that's what you normally want it on. Okay? Press 3 for me. You'll see it says f of x equals. Press cos for me. Now we need a variable. We're just going to call it x. Go alpha, so that it goes into the red mode, and find your x next to the SD button. So now you have cos x. Press equals. If you have a g of x, you can just make it 0. Sometimes it has 2 possibilities, sometimes only 1. Okay, where did your Cartesian plane start? What was the first number you wrote down? For the x's. Negative 360. So put in negative 360, press equals. Where are we ending? Positive 360, press equals. How did we jump from point to point? In 90. So put 90 in there, press equals. And there's your table. So when it is 360 for x, your y is 1. When it is negative 270 for x, your y is 0. When it is negative 180 for x, your y is negative 1, and so on right through to the end. I could even go and put, since my calculator is set to have both, I can even put both of them in. Sine x, starting at 360, going to positive 360 in steps of 90. It's going to take a moment because it's got a lot of work, and now I've got my values as well for the sine. So now you obviously need to remember that that was cos, that is sine. So for negative 360, it should be 0. That's exactly what I calculated when I did it the long way. You can do this with any grade 10 function. Just saves us some time, but you still actually need to know what's happening. So now I'm going to go and plot those onto a Cartesian plane. What y values am I oscillating between? Which y values do I see? 0, 1, and negative 1. I don't see anything bigger or smaller. So my Cartesian plane doesn't have to be much bigger or smaller. Calling it theta, okay. So we're going to 1. I'm going to make it on my third line just so that it's as big as possible. And negative 1. On my x-axis, or my theta axis, I will still go 1.5, so it's just a little bit bigger. You can do 1 centimeter, it's fine. I'm going to also use 2 different colors for the cos and sine graphs, just so that I can keep track of which is which. So for sine, I'll make it red. Remember, this is 90, 180, 270, 360, minus 90, minus 180, minus 270, and minus 360. So doing my cos graph second, my sine graph first. So 0 at 360, negative 270 and 1, negative 180 and 0, negative 90 and negative 1, 0 and 0 for y, 90 and 1, 180 and 0, 270 and negative 1, and 360 and 0. And I'm going to create my wave. And there is my sine graph going through the origin. A mother sine graph goes through the origin. Choosing a different color for my cos graph. 360 was 1. 270 was 0. 180 was minus 1. 0 and minus 90. 0 for x and 1 for y. 90 and 0. 180 and minus 1. 270 and 0 and 360 and 1. Creating my wave in green for cos. You will get used to drawing it, so it will look funky at first, takes practice. Okay, so my red graph is my mother sine graph. So mother sine, and it goes through the origin. Now I'm specifically showing you the mother graph because all shifts will go from what the mother graph was to what I'm going to change it to. So we're always comparing it to the mother graph. And my green graph is my mother cos graph. And this goes through the axis, through the y-axis at 1 in the mother graph. Now there are some things that we can see from this graph. What is the range of these two functions? So I'm looking for the y values that these functions can and do take on. never goes past +1 or -1, right? Okay. I can also tell that the distance from the middle to the crest each time is the same. Going from 0 to 1 and from 0 to -1, it's still a distance of 1. I can also look, when does the graph start repeating? So if I'm starting at 0, nothing is the same yet, nothing is the same. As soon as I get to 0, I'm going to start repeating, aren't I? It's going to be the same kind of pattern. We call that a period. So for a sine and cos graph, or sine and cos mother graphs, it repeats every 360 degrees. Now let's look at my cos, just focusing on my green. Going down and then up to 1, and then I would start again, wouldn't I? Going down and then up to 1. So once again we have a repetition. So there are some things that we can fill in on this graph, and we will write in the definitions that go with it. From 0 to 360 on the mother graph shows me the period. Just like we have 6 periods in the day, it's the same word, period. From the center of my graph, which happens to be the y equals to 0, to the crest is my amplitude. And we also have from the maximum value to the minimum value, there's my max, there's my min, is my range. So let's write some of these things down in words. Yes, Erin.
The amplitude is can it just be for the red?
No, the amplitude would be the same thing in the green. So for instance, I can draw it here. From any point that's the center of the graph to any maximum or minimum value is my amplitude. So we'll write that down. Amplitude. From the center of the graph to any extreme. Okay? Just note here, the center is equal to y equals to q. So whatever the q value is from my equation is where the center of my graph is. So if I had sine theta and nothing else, that means my q value is 0, and that was the center of my graph at y equals to 0. Then we have another bit of information, a period, the amount of degrees it takes for a graph to start repeating. For a mother sine and mother cos, the period is 360. Okay. Another thing to note is that a period is influenced by that p-value. So to find the period, we take 360 and we divide it by that p-value. So for instance, here we had 1 theta, so we're saying 360 divided by 1 is still 360. If it was 2 theta, then our period would be 360 divided by 2, which is 180. So to find the period is 360 degrees divided by that p-value from the equation.
Can you go up second to the range and the mean value? Is it just that one?
Okay. Now the maximum value is the maximum y value that you can achieve on a sine or cos graph. Okay, so the maximum is the highest y value. And we can do it or find it by the following. Taking my q value from my equation and adding a. So the maximum value is q plus a. What do you think the minimum would be? Is the lowest y value. And it is also my q value minus a. And my range will go between this maximum and this minimum, and at least this is true for grade 10. Okay, so my range, just like it is before, goes between my minimum and my maximum. But remember, it won't be theta because theta is an x value. So it will be your function going from the minimum to the maximum. So I'm just going to say a function, or f of x, or g of x, the entire function going between the minimum and the maximum. So we do not, these kinds of questions, what is the amplitude, what is the period, what is the minimum, what is the maximum, what is the range, we don't actually need to see this on a graph. If we have the equation, we can answer all 5 of those questions. And that is what we're going to start with. So I'm going to give you something. F of x equals to 3 sine theta. Start easy. I want the following. I'm going to give you a couple. G of x equals to 4 cos 2 theta. H of x equals to, let's say, 5 sine 3 theta minus 2, and one more equals a half cos a half theta plus 3. And for all 4 of them, I'm going to answer those questions. What is the amplitude? What is the period? What is the minimum, the maximum, and the range? So I'm going to do that in a table. So let's say amplitude. Let's say period. The minimum, or we'll do the maximum first, then the minimum, and then the range. We're going to do it for f of x, leave some space, g of x, h of x, and I of x. I'm just doing it so that I can keep it all on one page. If you want to do it below each other, please feel free. Yes. Yes, you can. Please hurry, because I cannot wait for you. So like I said, we're just going to look at those equations. So the amplitude, so just for the sake of writing it here, so I'm going to call it, let's say, P of x equals A function p theta plus q. Okay, just keeping our standard form close. And remember, your theta is bracketed and that plus q is a loose value at the end, not part of the theta. So, if I have 3 sine theta, what is my amplitude in 3 sine theta? It's just the number 3. Just like we had gradient on a straight line, it's just the number 3. Have I influenced my period at all? Is there a number attached to theta? No. So what is the standard period of this sine graph? 360 degrees. Now, my notes say that the maximum is the q value plus the a value. What is the q value in this first one? Do I have a q value? So what is it? 0. What is my a value? 3. So q plus 3, q 0 plus 3 is 3. So my maximum would be 3. 0 minus 3, so you just take the number, not the sign, would be -3. And lastly, my range would be from -3 to my function of f of x positive 3. How would this change my graph? What would this look like if I had that standard sine graph and now I'm saying 3 sine theta? So I'm just going to show you quickly what this looks like if I had to draw it. So I'm going back to my mother sine graph, which is red. Okay, and now my amplitude, which was 1 in a mother graph, is now going to be 3. So that would be 2 there, that would be 3 there. So it is creating a graph which hasn't shifted but has grown taller. So still following the same pattern of the waves, but it has stretched out. So from the center of 0 to the extreme value is now 3 units. That is how it has changed my graph. Okay, so let's try and do, I'm going to give you a moment, or let's do g of x together. What is the amplitude in g of x? What is the period? Well, now we need to be careful because the period has been influenced. So remember, period is 360 degrees divided by that p value. So 360 divided by the 2, what is my new period? 180. My maximum is q plus a, my minimum is q minus a. So just taking the numbers, the q value is 0. So plus the amplitude of 4, my maximum is 0 minus 4. And then my range would therefore be from -4 up to and including the function up to 4. Let's look at h of x. What is my amplitude? 5. How is my period influenced? So we're dividing by 3. My new period becomes 120. So my new period is 120 degrees. My maximum is q plus a. What is my q value here? -2. Okay, so it's kind of a tricky one. -2 plus a Negative 2 plus 5 gives me the positive 3. And negative 2 minus 5 is negative 7. So what is my minimum and maximum values? So my graph will oscillate between negative 7 and 3. Now do the last one for me, please. Yes, I've included the fraction, so make sure you divide by the fraction. And then I'll show you how this influences the graphs. Yes. The what? The one on the x. It's I of x. So that's what I've called it, is I of x. I should have actually said I of theta, shouldn't I? Because theta is my variable. Sorry, I of theta. Because I'm making everything as thetas. It's not the end of the world. It's just good etiquette to keep it in your calculation. To find what? So you're going to say 360 divided by a half. So make sure the whole half stays at the bottom. Okay, my amplitude is a half. My period, 360 divided by half, actually doubles to 720 degrees. My maximum is plus 3 plus a half is 3.5. So, sorry, it's 3 plus a half. And this would be 3 minus a half, which would be 2.5. And therefore my range would oscillate between 2.5, where I of theta goes to a maximum of 3.5. Okay, so what I need you to make sure you can do is find the amplitude, Haley, finding the period, finding the minimum, finding the maximum, and finding the range. That is what I need you to be able to do. And I need you to be able to draw a basic graph, the most basic graph ever. You can do it using, like I did the long way, type it in, type thetas, and find it. Or you can use it the way I just showed you, that your calculator can do it for you. Okay, that is what I need you to do for the exam. So what I'm going to do now is enrichment, just to show you what these graphs, how they affect visually. Don't need to do it this year, you will need to do it next year, but just how it affects visually. So we already know that an amplitude stretches it, right? Or if it was a smaller amplitude, it would squash it. Now I'm going to show you what a period does. So I'm just going to draw a very brief Muller sine graph. So there's 1 minus 1. Okay, 1 and minus 1, 90, 180, 270, 360, and that is my theta. I'm going to leave it as theta. That's y. That would make it 2. That would make it 3. That would make it negative 2. Would make it negative 3. Okay, so drawing a Muller sine graph. When I make your practice ones, I'll make sure to put in some extra things for you to practice. Okay, mother sign. So obviously you would use your calculator until you get used to knowing what a mother sign graph looks like. So taking a mother sign graph, so this is sine theta. I'm now going to go and take one and call it 3 sine theta. So if you had to put on your calculator, you would find that you have the following using a different color. Would still be 0, but my amplitude from the center to the extreme is now 3. From the center to, it'd still be 0. From the center to the extreme would be -3 and still be 0. So we've just gone and stretched the outer parts of my curve. That's all I've done. I can also squash it. Okay? So in red, I will do a half amplitude. So y equals a half sine theta. That means from the center, because there's no q values, so my center values here, to the maximum now would be there. So I have squashed it, still at 0. So we would normally, in a normal year, investigate all these things and make our own conclusions. Okay, so an amplitude, a big amplitude will stretch it, a small amplitude will squash. Okay, now we can also shift a graph up or down. And that is what is influenced by my Q value. So I'm going to take my mother graph, my brown graph. Make it in black. Okay. So remember, when I shift, it means every part of my graph would go after that shift. Okay. So if I now said plus 2 units, am I moving up or down? So I'm going to move up. So just focus on this point here. 1, 2 units. Where is the center of my graph? My Q value, right? At 2. So now what is my amplitude? Has my amplitude changed if this is y equals to sine theta plus 2? Amplitude is the same. So from the center to the maximum is still my amplitude. From 2 to 3, still a value of 1. But now, to find my minimum and maximum values without doing the graph, well, it's from my center plus my amplitude, from my center minus my amplitude. And the last thing that I want to do is I want to show you what a change in period does. So if an amplitude stretches and squashes that way, a period change would stretch and squash that way. So for instance, if I took the same graph of my same mother graph, so we're going to call it y equals to sine 2 theta. That means my period is 180 because 360 divided by 2 is 180. That means that my amplitude is still 1. And the period means it starts repeating every 180 degrees. So taking your mother graph, and I'm going to squash it, which obviously I can't do visually, but what it would look like. Can you see at 180 degrees I can cut and paste onto the next graph. So I took my mother graph and I squashed it in a bit so that I can get more waves in that same degree pattern. So those 5 things that we wrote down today and drawing the basic graph is what we need to know for that test. Amplitude, range, minimum, maximum, and period, and a basic drawing of a graph. Tomorrow we start analytical. Yes, Eric.